Training, validation, and test sets. Whenever you decide to make a machine learning model, you have to decide how to make the best use of the data that you're having. Let's say you are having some data D. This data will have your x and t. What is x? X is the observations or the independent variables, and t is your targets. So you will have a long list that for this value of x and t, for this value of x, this is the target t. This value of x, this is the target t. This value of x, this is the target t. So you will have a very large data with you. And what will you do with your model? You will have, let's say, some model y is equal to w0 plus w1x. You will make this model learn. How will you learn? You will use a value of x. Using that value of x, you will try to predict some value of t. Then whatever the value of y that you got, that is your prediction. Now you will compare what you got with this value of t. Whatever is the difference, that is your error. Error is y minus t. Now using this error, you will try to optimize w0 and w1. So your model basically tries to find out the values of coefficients w0 and w1. As you find some difference in w0 and w1, you will adjust it and you will use the next piece of data. Next piece of data, you will do the same, and this is how you train a model. That is, you will use this x and t in order to train your model. So when you get this data, the first thing you have to do is that you have to divide this data into three parts. One is your training data, next is your validation data, and the final one is your test data. Training set, validation set, and test set. What is the need of these three different sets? And why should you make this demarcation right from the very first point? That is, right from the beginning, why should you make this demarcation? The training set. When do you use your training set? So as the name suggests, training set is used for your model training. What will you do? Whatever are the values of x and t in your training set, you will use that. You will provide x to the model. You will see what y it produces. You will compare that y with the t, and you will backpropagate. That is, backpropagation is basically the process of determining how much is your error and then accordingly updating your w0 and w1 and whatever be the coefficients that you have. That is what you do. So every time you will use value of x, you will find y, you will compare that y with t, and correspondingly you will update values of w0 and w1. So for this training process, this process is the training process where you train your model, you teach your model to learn the values of w0 and w1 and whatever w's you have. So this is the training process, and whatever data that you put for training, that is called your training set. So training is the most important process. So the larger chunk of your data that should come into training. So generally what people do is they either choose 80% or 60% depending on the situation. So let us consider 80%. 80%, that is the larger chunk of your data, should go into training set, because this is where you actually teach the model. This is where your model learns. So depending on the number of or the data points that are there in the training set, that much good your model will be, right? So allot the major chunk into training set. Now validation set. What is the need of validation set? Validation. So the need of validation set is that in the previous lecture, we learned about regularization. So what happened in regularization? In the regularization, we had an error term which was sum of squares error, plus we added a regularization term which was something like this, lambda by 2 into w square. So here you have to determine this regularization parameter called lambda. So these are called hyperparameters. The parameters like lambda, these are called hyperparameters. So to identify this regularization parameter, we discussed that depending on the value of regularization parameter, your model may overfit, underfit, or find the sweet spot where it doesn't overfit and doesn't underfit. So basically you want to find the value of lambda which is in the sweet spot where the model doesn't overfit, it also doesn't underfit. You don't want these two. So how do you find the right value of lambda? For that you need one particular data set that is kept exclusively for this purpose. That set of data is the validation data. So what will you do? Initially, you will train the model. You will train the model using this. So that is done on this training set, let's say 80%, and let's say 10% is your validation data and 10% is your test data. So once you are done training the model with your training set, now you will take the trained model. This is your trained model. You will use your validation set data. So you will have the same values of X and T in the validation data set. You will give the value of X as input. You are giving X as input. Using this X, your model will run. Now it is already learned. So it just has to run and find the value of Y. It will find the value of Y. Now you will compare this value with the same value produced when you give a different value of lambda. So this comparison you have to do using validation set. And from validation set, you will identify what is the perfect value of lambda that you need. So this is the need of validation set. Now let's move on to test set. What is test set? You've done training, you've done validation. What is next? What is remaining? You want to test your model. So here there is one major rule, that is, normally whenever you are training any machine learning model, you mostly use this test set only once in the total lifetime. You never use it before, because if you use this test set before at some point of time, let's say you inserted a bit into training, then what is the point of testing finally? The whole use of testing is, before you use this model in the real world, before you put this model out, you want to see how good is this model performing. That is, previously we discussed about the concepts of overfitting, underfitting and so on. Let us say your model did overfitting, which means on your training data, the model will give very less error. Maybe your accuracy is 99%. That is if your model fit perfectly onto training data. But when you finally do a testing on the test data, you will understand, oh, my model is only having 30% accuracy, which means your model did overfit. So to identify and understand what is the actual performance your model is going to give if you put it out in real world, that you understand from the test set. So do not use test set during any of the previous phases, training, validation, anything. You use the training set, train the model, then you use the validation set, identify the right hyperparameters. Once you are done with everything, you have the final model ready. Before you put this into real world or put this into any application, use the test set. Use the test set, the value of X and T, put this value here, see what is Y, compare it with T. This is just for analysis. Here you will simply analyze how much is your Y closer to T, and you will identify that my model is having, let's say, 85% accuracy. So this is the real world accuracy. So the requirement of test set is that once you do a testing on test set, which is the data your model has never seen before, you will know this is your real world accuracy. Now you put this into any of the real world situation, whichever data you give, you can expect that on average you will get 85% accuracy, because you know your test set was never seen by your model before, and you simply gave this new data from nowhere and your model gave 85% accuracy. So ideally you would have a 80-10-10 split or a 60-20-20 split. 60-20-20 split for train, validation and test. When do you want to use only 60? That is, if you have enough data that your 60% data is already good enough to train your model. In that case, you can go for 60-20-20. Otherwise, if you think 60% of the data is not good enough to train, always choose the 80% split, because you always want major chunk of your data to be used for training.